For now, the fourth block, electricity and magnetism and their applications, okay, in May-June 2020, paper 2-1, okay, the multiple choice question. In the question number 26, what do we have? 4 nails, A, B, C, and D, okay, are what tested to find which makes a strongest what permanent magnet, okay? One of the nails is placed against the bar, a bar of magnet, okay? And the number of paper clips which is the nail can what support is recorded, okay? How many paper clips are attached to this nail is recorded, okay? The bar magnet is then what removed, and the number of what paper clips remains attached to the nail, okay, is recorded before. So when there is a magnet bar attached to the nail, okay, how many paper clips, and when remove the magnet, okay, from the nail, how many what paper clips still, okay? Each nail is tested individually. Which nail becomes the strongest permanent magnet? Now, in this question, we have to know that the number of paper clips, they have to be huge and still huge. Okay, so if it was 2 and becomes 0, that means it's not permanent magnet, it loses all magnetism. If it was 2 and becomes 1, maybe it's still magnet, but we have to make it strongest magnet. If it was 4 and still 3, yes, this one is good, better than C is better than B. Okay, if it was 5 and fall to 2, so it's not still a permanent magnet. Okay, so the answer is what? Thank you, Saif. Thank you, Muhammad. The answer is what? Is C for question number 26. Good, is it clear? Okay, question number 27. The circuit shows, okay, one method of magnetizing a steel bar. We have 3 methods to make a magnet, okay, magnetize a magnet, and 3 different methods to demagnetize a magnet. Okay, so what do we have? We have a DC source connected to what? A solenoid, and we have to put the steel bar inside it for a certain time as we turn on the circuit, the supply, to become what? A strong magnet. What do we have here? How can the circuit be altered, okay, so that it can be used to demagnetize the magnet of the steel bar? Okay, now if I want to make it demagnetize, not make it magnetize, I need to make one change. Who can tell me what this change is? Which one is the answer for question number 27? Remove the steel bar from the coil while the current is switched on, or replace the DC by AC supply and gradually reduce the supply voltage to what? To 0, okay? Or reverse the polarity of the DC point, okay? Or reverse the polarity of the DC supply, okay? Gradually reduce it to 0. Now we know that for making DC, we make it magnet. If we replace it from DC to AC, okay, and we remove it slowly, or what, we reduce the voltage or the current slowly until it becomes 0, we demagnetize the magnet. So the correct answer, yes, thank you, Muhammad, Sarah, and Muhammad, okay, Saif, and all of you. The correct answer is what? Is B, okay? But what about the rest of you? What about Hazem and Sandra, Sidra? Okay, I want to hear your answers or see your answers. Send it to me in the chat. Okay, now let's move to question number 28. In question number 28, what do we have here? A student uses the circuit shown to determine the resistance of 2 identical what resistors, okay? So we need to determine how much is the resistance for these 2 identical resistors, okay? There's a meter, there's voltmeter connected across both of them, and there's a battery power supply or DC power supply, okay, battery. The voltmeter reading is how much? 2.2 volt, and the ammeter reads how much? 0.25. Calculate the resistance of each resistor. Now, since these are connected in parallel or in series, these are connected in parallel or in series. Yes, thank you, they are connected in series. So since they are connected in series, the combined resistance for both of them, okay, it's the addition. And since they are identical, that means the resistance, for example, if this is R and this is R, the combined resistance for both of them, it's what? It's 2R. So the combined resistance in these, because they are in series, we are adding them, R plus R, which is 2R. And we know that also that the formula for the voltage and the current V equal IR, and R here is 2R. So the voltage, which is 2.2, and the current is 0.25, so that means it's 8.8, okay? Multiply by what? 2R, okay? Divide by 0.25, divide by 2, divide by 2. So R equal how much? 4.4 ohms. I divide by 2, okay? So the answer is what? The answer is C. Yes, thank you, Shabab. Yes, correct. Good. What I did here, I divide by 0.25, divide by 0.25, so 2.2 becomes 8.8, and 2R remains 2R. So divide by 2, divide by 2, 8.8 divided by 2, it's 4.4, okay? Yes, correct. Next, question number 29. What do we have here in this question? An electric fire is connected to what? Okay, it's connected to a 240 volt supply and transfers energy at a rate of what? 1 kilowatt. So the power, the energy transfer at rate, that means we are talking about power, and the power is how much? Is a 1000. An electric, they're supposed to say an electric fire alarm or electric heater. I don't know why. What's the electric fire? Okay, maybe fire means fryer, not fire, heater. Okay. How much charge passed through the fire or the fryer in what? In 1 hour. Now we know that. What do we know? Yes. They give us the time here. Yes. What is the formula that I'm going to link the power with the energy with the time? And they ask about, well, how much charge? Yes, thank you. Bravo. We know that voltage equal energy per charge. So I have to know how much is the energy. So first step, we know that power equal energy divided by time. That means energy or work equal power multiplied by time. And the power is 1000 multiplied by the time, which is 1 hour, 3600. Yes, it's 60 minutes times 60 seconds. So it will be 3600,000. Okay, this is the energy I substituted here. Okay. So it will be, I'll do cross multiplication. So, okay, Q equal the energy divided by what? Divided by the voltage, which is 240. And by using the calculator, how much is the answer here? It will be 1.5 times 10 power of 4 coulomb. So again, what we did here. First step, what did we find? Let me rearrange this. So when you take a screenshot, okay, you will find it out clear. First step, we find how much is the energy for 1 hour. So we know that power equal energy over time. That means energy equal power times time. And it was 3600000. Why? It's the power at 1000 multiplied by the time, which is 3600. This is the first step. Then what we did here after this, we find how much the charge by using the formula, what? Voltage equal energy divided by charge. This is the definition of what? Of the voltage. Voltage is the amount of energy given by one charge. So Q equal what? Energy divided by voltage. So we divide this value over what? The voltage, which is 240, and the answer is 1.5 times 10 power of what? 4. Okay. Okay, what about if I use formula P equal IV? So I can find the what? I can find the current, then I'll use the time to find the charge. Yes, you can do this. Also, you can use this way. This is another way. What we can do, first step, we can find P equal IV to find how much is I. Then we said that current equal charge divided by time to find how much is what is the charge. So in electricity, you can see if we can use this formula, 1, 2 steps, or you can use these two formulas, first and second step. It depends on how you think in the question. Okay? Yes, correct, Muhammad. Thank you. And we'll still get the same answer for sure. Yes. Okay. Now let's move on to question number 30. Question number 30. The diagram shows an incomplete circuit. As you can see, we have a cell, we have a meter, and we have PQ with something missing here. The temperature and the light level around the circuit remains unchanged. So the temperature doesn't change and the light level doesn't change. So they are saying no thermistor, no what? No LDR. Okay? Tamam. 4 electrical components are connected in turn across PQ. The cell is reversed and the 4 electrical components are connected again, okay, in turn of PQ. For which component is there significant change of the magnitude of the current? Significant change. They say that the temperature and the light level doesn't change. That means neither the LDR change or the thermistor can change. So which component, the diode or the resistor, if I put it, I'll make significant change. Now, if I put the diode here, for example, in this situation, the current will flow. If I reverse the cell, the current will not flow. So that means the current will block it. The diode is blocking the current if it reverses in the opposite direction. So the answer is what? The diode, which is what? A. Again, ya shabab. In this question, they said that the temperature and the light level, okay, unchanged. That means there is no change of the resistor or the reading of the ammeter, okay, and the current, because there is no change of the temperature and there is no change in the light level. So that means the light dependent resistor and the thermistor, they don't have a huge change in the reading, magnificent change, okay? Fine. So how we can make a huge change if there is what? If there is a diode, because the resistor, in both ways, there is current. If I connect the diode, in both ways, I reverse the cell, there is a current, and the current will be the same, but one is positive and one is negative, or one to the right, one is the negative, okay? But how we can make magnificent change to the magnitude, the value without negative sign of the current? So the answer is what? Is the diode, okay? Good? Okay. Number 31. What do we have here? In the circuit shown, A1 and A2 are ammeters. A1 and A2 are ammeters. Switch is closed. Switch was open and we close it. Which row is correct? Now, we know that the current that come out from the cell here and return back to the cell here is the same. So that means the reading on A1 and the reading on A2 is the same before and after what? Closing the switch. But as the switch is closed, these two resistors, they are connected in what? They are connected in parallel. So as they are connected in parallel, that means there will be current here and current here, different currents. So that means as we close the switch, the current will increase or decrease. The current will what? Increase. Now, what they said, the resistance of the whole circuit decrease. Why? Why? Because in combined parallel resistors, the combined resistance decreases. Reading of A1 stays the same. No, it's increases. Okay, and reading of A2 also what? Increases. So the answer is what? Is B for this question. Again, if we have only what? The switches was open, that means this not connect. So the current will pass only from the cell through A1 and the resistor and A2. So the reading, for example, let's say 0.3 ampere. Okay, now when we close the switch, that means here there's another current pass here. So that means the current, because these resistors are identical, okay, they didn't mention, but that means if the total resistance in the circuit will be what? There will be more current here. So that means the current will be higher than 0.3. Okay, why? Because both resistors, they are connected in parallel. So with the combined resistance will decrease. That means the reading on A1 and the reading on A2 is what? Is increased. Okay. The answer for 31 is B. Okay. Even in the mark scheme, I think it's B. It cannot be what? It cannot be A. Tamam? It cannot, this one stays the same and this one increases. Cannot make one of the readings A1 stays the same and reading if A2 increases. This is impossible because we are talking about the same thing. Okay. Tamam. Number 32. What do we have in number 32? Which symbol represent OR gate? Now we know that A is OR gate. Tamam. B is NOR gate. C is AND gate. And D is NAND gate. Okay. Easy questions. Some questions they only need to read it to answer it. It doesn't take that much time from you. Question number 33. Oh, this takes a long time. A digital circuit contains two of logic gates. Okay. When the input, okay, when the input to the circuit is 1, 1, the output is 0. Okay, 1, 1, the output is 0. Which combine of logic gates, okay, gives this result? Now, let's see each one by itself. 1, 1, this is NAND. Now we know NAND is the opposite of AND. So 1, 1 for AND, it will be 1. For NAND, it will be 0. And this is what? This is NOR, not gate. That means it will reverse what? To make it what? 1. So it's not the answer. Now let's go to B. In B, we have 1, 1. Okay, this is not gate, that means 0. And this is 1. And this is OR, that means the answer, it will be 1. OR gate, 0, 1, it will be 1. So also, this is not B. Okay, 1, 1, move to AND, it becomes 1. This is not gate, it becomes 0. So this is our answer. Okay, the output 0. Let's check the last one, 1, 1. Okay, this becomes 0. So 1 and 0 move to NAND, which is the opposite of AND. So 0 and 1, it becomes 0. NAND, the opposite, that means it will be what? 1. So it's not D. So the answer is what? Is C. Okay? Is it clear? Thank you, Muhammad. Thank you, Maryam. Is it clear? Okay. Number 3, why not B? Okay, let's see what's happening here. Okay, now what do we have here? 1, 1, 1, 1. Okay, here there is not. What do we have to not? Reverse. If it 1 becomes what? 0. Now 0 and 1, they go to OR gate, and the output is what? 1. They said that the output is supposed to be what? 0, Muhammad. Okay, clear? Okay. Number 34. What do we have? The diagram shows a wire, okay, between the poles of a magnet. The wire is perpendicular to the page, and we have north here, we have south. They said right, left. Okay, no problem, Hamid. Okay, so we have a wire. Okay, they said that the wire is moved and the current is induced. So we have to move the wire, and there is induced current. Okay, upwards. Okay, the wire is moved and a current is induced upwards out of the page. That means the current is out. That means that's why they put dot, out. Induced current out of the page. In which direction does the wire move? Okay, now here we are going to use, because we are talking about electromagnetic induction, electromagnetic induction. So we are going to use what? Right hand rule or left hand rule? Bravo, we are going to use Fleming's right hand rule. Remind you by Fleming's right hand rule. Fleming's right hand rule, we have 3 dimensions here. We have thumb, we have first finger, we have second finger. Now we know that the first finger is the magnetic field. It's from north to south. And second finger is the current. They say that the current is out of the page. And the thumb show me the motion. So first field, second current, thumb motion. Okay, so the first finger is going downwards and the second finger is going out of the page towards me. So in which direction is the thumb? Into the left. So the wire is supposed to move to where? To the left. Again, so the first finger is down, the second finger is out of the page. Okay, and the thumb is going to where? To the what? To the left. So in which direction does the wire move? From what? From right to left. So the answer is what? Is B. Okay, again, this is the direction of the magnetic field. This is the direction of the current out of the page. That means this is the direction of the motion. Okay, good. You remember that, right? Okay. Let's move on to question number 35. In question number 35, okay, 35, 100% efficient transformer, okay, 100% efficient transformer at the end of the class, Mohammed. At the end of the class, I will explain to you again, okay? 100% efficient transformer converts a 240 volt, okay, input into a 12 volts. So this is the voltage in the primary coil, and this is the voltage in what? In the secondary coil, okay? The output power of the transformer is the maximum to be what? To be 20 watt. This is power out, power what? Secondary, okay? The power, the output is connected to what? To what? 0.3 bulb in parallel, okay? So that means the total current in the secondary is what? Because they are in parallel, is how much? 0.6 ampere, okay? What they ask here, okay, one of the bulbs fails. When one of the bulbs fails, that means the current return back to this one, 0.3, okay, ampere bulb, okay, the current. How does the current in the primary coil changes? Now, we need to find the current first situation, then what? Second situation, and we find how much it decrease or increase, you can say, or remains the same. So that means I'll do this twice. First, we know that IV is equal to IV. Why? Because they said it's 100% efficient. So I secondary, V secondary equal I primary, V primary. I secondary was how much? 0.6 multiplied by the voltage secondary, which is 12, equal I primary, that we want to find it out, multiplied by how much? Multiplied by 240. How much is the answer by using calculator? If you have a calculator, give me the answer. The current in the primary is equal to how much? Divided by 2 here, divided by 12, divided by 12, it's 20. So it will be 0. What? 0.3, right? Yes, 0.03. Okay, this is the current in the first situation. Thank you. The current is the second situation. I'm going to use the same formula. I secondary, V secondary equal I primary, V primary. But here in the second situation, the current is not 0.6, it's 0.3. So 0.3 multiplied by 12 is equal to I primary, that we want to find it out, multiplied by what? 240. By using the calculator, how much is the I current in the primary in the second situation? It will be 0.015. So that means, does it increase or does it decrease by 0.015? It decreased by 0.015 because it was 0.03, okay, 0.03 ampere, and becomes how much? 0.015 ampere. So the current decreased by 0.015 ampere. So the answer is B. Good. Any question? Okay, let's move on to question number 36. In question number 36, cable transmission electrical power from the output of transformer at power station into the input of transformer at what? Substation, okay? Now these are the cables. We have transformer at the power station and transformer at the substation, okay? Input, output, okay, output, input, as you can see. The power at the output of the transformer power station here is what? 400 megawatt. 400 megawatt, million watt, 400 million watt, megawatt, okay? Which situation deliver the most power to the input of the transformer at the substation? How much can we make the most power reach here? Okay, the potential difference across the power station transformer, or the output in kilovolt, is it 200 or 400? The diameter of the cable is supposed to be large or supposed to be small. Now, whenever the cables of the diameter is larger, that means what, ya shabab? it has less resistance, so less power dissipated, so the most power reach. And also, the power between the cables, they have to be high or low. They have to be high, okay, because whenever the power is high, the current, it will be low, so the power lost, it will be low. So here, why I need the cable, the diameter to be large? Less resistance. Okay, and why I need the voltage to be high? To have low what? Low current. So if I have low current and less resistance, the power dissipated or the power lost is equal to I squared multiplied by R. So whenever the current is lower and the resistance is less, the power dissipated or the power lost due to the transmission cable, it will be less. So that means I will deliver the most power, okay, to the inputs and of the transformer at the substation. So the answer is what? The answer is C. Okay, clear? Next, question number 37. We can see that these are talking about nuclear physics. What they ask: uranium-235 is radioactive isotope. It undergoes a chain of decays and eventually forms a stable isotope of lead-207. These two isotopes are represented as shown: uranium-92-235, lead-PP, okay, 82-207. Okay, during the chain of decay, how many proton and how many neutron are lost from a single nucleus of uranium to form a single nucleus of lead? Now we know that the lower number, we call it the atomic mass, okay, it's the number of protons. So the difference of these values is the number of protons. So 92 minus 82, it's 10 protons. Okay, so the answer is 10 protons. And also, we know that the nuclear number, the number on the top, is what? The number of protons and the number of neutrons. So that means protons plus a neutrons, okay, it's equal to what? To 235 minus what? 207. And the answer, it will be what? How much the answer? It will be 28. That means neutrons and protons. But I want to know only how many neutrons. So N plus 10, N plus P equal 28. That means N, it will be minus 10 minus 10. It will be 18. So the answer, it will be 18. And the answer, it will be what? It will be A for question number what? 37. Is it clear? Again, we subtract the atomic number to find how many protons. We subtract the nucleons number, how many protons and neutrons, which is 28. Then we subtract the 10 from the number, which is 28. Good? Clear? Okay, next question. What do we have here? A radioactive material has a half-life of 20 days. This is the half-life. A sample of material contains what? 8 times 10 to the power of 8 atoms. This is the number of what? Atoms. Now, okay, how many atom nuclei have decay after what? 60 days. This is the time. Now I told you we have two different ways to answer this question. I will use the table method now. Okay, for example, this is the time, and this is what? The number. Now the time is 0. The number is what? 8 times 10 to the power of 10. After first half-life, I'm adding half-lives here. After first half-life, which is 20 days, the number here, it will be divided by what? Divided by 2, so it will be 4. After another half-life, 40, it will be divided by 2, it will be 2. After a third half-life, 60, I'll divide by 2 also, it will be what? 1 times 10 to the power of 10. So the answer is what? Is A, after 60 days. Clear? So again, we make a table for the time. We start from 0. And how much was the activity now? It was 8, our number of atoms. It was 8 times 10 to the power of 10. We keep adding half-lives, 20 and 20, 40 and 20, 60 and 20, 80, etc. Okay, here we keep dividing by what? By 2, by 2, by 2. Okay, divide by 2 is 8, divide by 2 is 4, divide by 2 is 2, divide by 2 is 1, divide by 2 is half, etc. They ask after how long? After what? 60 days. It was 1 times 10 to the power of 10 what? Atoms. These how many what? Okay, that's sorry. They ask how many atoms of the nuclei have decayed. This is what left. This is what left. So 8 minus 1, it will be what? 7. So the number of atoms that they decay, it will be what? 7 times 10 to the power of what? Of 10. But how much left? It's 1 times 10 to the power of 10. So the number of atoms that they decay, or the number of nuclei that they decay, okay, after 60 days, it will be the total number initial minus the total number remains final, okay, and it will be 7 times 10 to the power of what? 10. Okay. Next, question number 39. What do we have here? Question number 39. A thin sheet of paper is placed between the radioactive source and radiation detector. This is the source, this is the detector connected to a counter. The counter rate falls to a very low reading, to background radiation, okay? So when we put a paper and it falls to background radiation or very low reading, negligible reading, okay, that means some of these, okay, sources, okay, of radiation, it's caused the paper absorbed by it. So from the list, which type of radiation? Okay, thank you, Muhammad, thank you all of you. The answer is what? Is alpha. Alpha is absorbed by paper, absorbed by paper. Beta can pass, so the reading does not change, very low reading, okay? Gamma, not affected by paper. X-ray is not nuclear radiation, actually, okay? Last question for this year, what do we have? Alpha particles, beta particles, and gamma rays are emitted by radioactive nuclei, okay, when they decay. Which emission can be deflected by electric field? Now we know that alpha is positive, positive 2, beta is negative, negative 1, and gamma is a neutron. So which one of these will be affected by electric field? Alpha and beta only. So the answer is what? A, no gamma, no gamma, no gamma. Okay, so the answer for number 40 is A.